Hey, good afternoon, everyone. This is Kenny Hart with Neometrics Tech. I'm the sales engineer with Neometrics Technologies. If you guys haven't sat in on any of my webinars in the past, my contact info for any reason, if you want to get a hold of me for any of the products we see here or general questions about some of the stuff you may see, 3D scanning, reverse engineering, inspection, things like that. You can reach me at my email, kenny@neometricstech.com. But to kick off to today's webinar, our subject today is going to be GeoMagic for Solidworks. So GeoMagic, those of you who may know, they're one of the forerunners in definitely in reverse engineering with their GeoMagic Design X software, as well as their inspection software, GeoMagic Control X. Design X is the absolute best reverse engineering software on the planet. It is a very expensive software, so GeoMagic for SolidWorks is a great option because it takes the most commonly used tools, most of the tools that you'll be able to use to actually get a complete model, extracted from a scan in your SolidWorks workspace. So you're working, if you're already a SolidWorks user, you're going to use your SolidWorks license and actually build your model within that. Let's go ahead and start that. How's it going, everyone? So we're just going to scan this little demo part. It's a gray plastic injection molded piece. And the scanner we're going to use today is the new GoScan Spark. This is handheld, not connected to anything except for the data cable. And we'll start shooting. So as you can see, this is actually a white light scanner as opposed to Creaform's other laser scanners. And this scanner will capture geometry as well as color. So if you do have artwork and things like that you'd like to recreate in three-dimensional space with color, this is a great option. You set the scanner down. But again, this guy, GoScan Spark, accurate to 50 microns or about 2007 inch, one of the fastest 3D scanners on the market. So I've captured the part as well as the table. Now I do want a little bit of the table left. So there we go. We're going to do an inverse selection. Again, this is VX Elements. This is Creaform software. You can bring into your extraneous pieces floating around are actually going to not be exported due to this remove isolated patch setting I've got. So it looks like we're good to go. That's a pretty decent amount of scan data there. So let's do a file export of the mesh. All right, and that's the whole scan process. So if you had a second half of the part, you flip it over, click Add Scan, scan the other half, and merge them together. This one, we don't have to do that because the part's got a flat bottom. I'm just going to use the turntable. And I'm going to be, from here on out, going to be working in SolidWorks. So this is where the GeoMagic for SolidWorks comes in. To start a file, you would start just like a regular SolidWorks file. You're going to start a new part. Okay. And it's going to open up the part tools just like you'd normally use. Now, GeoMagic for SolidWorks is this tab on the very end. So it's an actual plugin within your main tool set. So what's awesome about this software is that you can use the GeoMagic for SolidWorks tool set to extract features. And then you can edit those features and it's going to build, everything's going to be parametric. So anything that it does, it's going to reproduce over here in your tree in a way that you can edit it. So to start, I do need to, instead of doing an open STL, to go to a file open STL, we do have to import it into the GeoMagic plugin, but that allows the software to configure the STL in a way that it can efficiently use it. So I'm going to grab that parametric model example, the one we just scanned, and click open. All right, I want to make sure, there we go, came in just fine. All right. So if we look at this part and we look at our orientation planes, this is pretty common. We can, the part's not oriented to our coordinate system. That's the first big step that this software, the big problem this software solves. Okay, so I'm going to go ahead and use the software to align the scan to our coordinate system, get it a little more where it needs to be. So let's hide those planes. And if you ever get a file from somebody that's been reverse engineered, and it's not aligned to the coordinate system, this is generally the problem. They really don't have a way to do so. They just kind of import the scan and they start to kind of try and build features around it where it exists. That is not what we're going to do. we're going to go ahead and align this part. So first step is we're going to divide the mesh up into regions. So this is a feature from GeoMagic Design X. And what regions do, or what regions are, they're basically areas on the mesh that the software recognizes as individual features, so we can then pull those features from the mesh. So the first thing I need is some reference geometry to get the scan to the coordinate system. And I can do that in GeoMagic for SolidWorks with these features. So I've got extract feature plane, or reference plane. I'm going to click on that. I'm going to click on my base feature. All right, I want the part aligned to that base. So click the checkbox. All right, I also want it aligned, let's just say on this corner here. Okay, so I need a couple more planes. We're going to do extract reference plane again. Click on that face. Okay, extract one more reference plane, click on that face. All right, so now to get my axis and my point for a 3-2-1 alignment, I can go right into my SolidWorks features, so I can seamlessly jump back and forth because these are now features in my coordinate or in my model tree here. All right, I'm going to go to reference geometry, axis, and I'm going to choose intersect from two planes. Okay, so we're going to choose a plane here, a plane here. All right, that's going to give me my axis. And then I'm going to choose a point because I want to choose where my origin is going to be, and it's going to be at the intersection of that axis and that plane. All right, so there's my origin point. Now I need one more axis going down the side of this part. I like to use the long edge. So I'm going to do one more axis. Again, intersect two planes, click plane 2 and plane 1, and there we are. So I'm going to go back to GeoMagic for SolidWorks tab, and we have the Orient Mesh button here. So we're going to click on this, ask us a few questions here. So first, select the mesh. We only have one, so it's already there. And now we can pick, so where's the origin? I want the origin to be on point 1, okay? And now I want to look at, with SolidWorks, the general isometric view is, I kind of want it to look like this, and usually the Y goes up, the Z runs in this direction, and the X runs in this direction. So what I can choose is Z-axis, and then click on this vector, okay? And that should snap the Z-axis that direction. All right, and then Y-axis, I'm gonna click on plane 1, okay? And that should get me how I wanna go. And my Y-axis is pointing down. I don't want that, so I can just flip it, and there we go. Now I've got my coordinate system lined up how I want. All right, so again, first big step is done. There we go. If I show my front, top, and right planes, you can see there I'm correctly oriented my coordinate system. So that's what we want to see. The rest of these features are actually no good to us anymore. They're out in space, so we can select everything and delete it. Okay, and now we're ready to model. So as we go through this, feel free to put in the chat if you got any questions or anything like that. I'll get to them. I'll run through this one and I'll try and answer the questions as they come in. So, all right, but we've got our coordinate system. We got our part aligned to our coordinate system. Now we want to start extracting our features, and this is where the tools get really cool. So if I want to make a solid part out of this, we've got a few extraction tools over here, and the first one is extract extrude. Okay, so if I click that, it's going to ask me a few different things. One, how do you want to extract it? I want to do it from the regions. And what I'll do is click the sides of my region, the side regions of my part. Okay, and you can see there's already trying to create a preview. So what it's going to do is it's going to analyze those regions, make a sketch, make a preview sketch, and then make a preview extrude. So what I like to do is go ahead and constrain my sketch plane. All right, so I'm going to make sure that my sketch plane is coming from that top plane. All right, there we go. And let's see what else we got here. I think that should be all the things I need. The other is the other end. I want to make sure it's dragged up above the part. All right. We got a few other options in here that we can mess around with, but we're just going to leave it. I'm also going to go ahead and check drafted extrusion because I want to make sure that the extrusion, whether it's drafted or not, this is going to find that out. So when I click my checkbox, it's going to create that sketch and it's going to create a solid body. Okay. So there's my extrude. Now what's awesome is you can see extrusion 1. If I drop this down, there's sketch 1. So it's created a sketch and an extrusion that I can fully edit in this software. So if I need to go in and change how high I need to, drag that extrusion, I can. So it came up with an auto draft angle at 1.17. Maybe I want to just go ahead and make that 1. Okay, make it a 1 degree angle draft. There we go. And now we're ready to move on. So to cut the part down, I'm going to hide the solid body itself. And now I need to get the part cut back to this top surface. So this surface here is an extremely hard surface to reverse engineer. There's no real good way to do it. There's nothing to measure from. It's just this weird, weird free form. So trying to make an accurate, there's no way to really make an accurate representation of that if you were trying to do this on your own. But this software lets us do it almost instantaneously. So we can say extract freeform. All right, same thing. It's going to ask us what regions to use. I'm going to click on that top region. All right, and we've got a few sliders here. So I'm just going to leave them as a default for now, and then we're going to click detailed preview. So if I look at it, one, I can kind of see it's not totally fitting. And I also have at the very bottom, I've got this deviation analysis tool. And this is really nice. So I can choose how close I want to measure that previewed surface to my scan. I'm going to make it 5,000. So that seems like a pretty reasonable number. And you can see it's not perfect. There's some blue and there's some green, which means there's some high and low points. So if I drag my accuracy slider bar, if it requires it to be higher, we'll let it regenerate that surface. All right. And I can already tell that looks a lot better. And you can see there's totally green. So I'm within 5,000 of an inch all the way across that surface. The other slider is enlargement. I don't have to touch it. It basically just the surface needs to be outside of the boundaries of the part so we can cut the solid. So I'm going to click my checkbox, and that's going to make it a really nice surface for us. So that surface is accurate to at least 5,000 of an inch, and we did it in just a couple clicks. That amount of time savings is huge. So, and now we can just use that surface. I'm going to show my solid body. All right, and we're going to use the Solidworks tool set. So insert, cut with surface, click that surface body, and make sure it's cut in the right direction. And we're done with that. So we're already working pretty fast here. So next thing I want to do, get that big pocket out. That'll be another extrude, is an easy way to do it. So I'm going to hide this again, okay? And then we're going to go back to another extrude. And here I'm going to click my region, all right? And then I can kind of figure out what I want to do here. So again, I want to do a drafted extrusion, okay? And then I want my sketch plane to be, let's see here. You know what? Let me throw a sketch plane in first, and then we'll do it. So let's do another extract reference plane. There we go. All right. There's a plane. Now we'll run it. So let's do extrude. Again, choose our region. I'm going to choose my sketch plane to be that plane we just extracted off that bottom face. And so it's trying to kind of insert a feature. That's fine. We're just going to do a new feature. And you see the preview sketch it's already made. So I can choose to just only insert a sketch and then edit that sketch and do an extrude cut. Or I can just take what it's given me for now. So let's click the checkbox. All right, there's my extrude. And I love SolidWorks' new tool sets. So some of their direct modeling tools, I can just click on that face, drag it this way until it's outside of the part, and then use the SolidWorks tool combine. So insert features combine. Okay, main body. Let me turn those solids back on. There we go. So main body is going to be our part. Bodies to combine. Click on that. And there we go. It's cut out. All right. So we've got a pretty good match here. Everything looks really good. Now, in addition to the extrude tools, we've got all of these other functions. So if I want, this cylinder here, I can click on cylinder. All right. And I can just click right on the cylinder and then choose to go up to, let's do up to region this way. And then click on that top region. And then on the bottom, we'll just drag it down into the part and make sure that our resultant operator is join. All right, and what it does is it creates a sketch. There we go. Creates a region surface. All right, and just insert a cylinder for us, super quick. All right, and everything's merged up. If I want to do the same thing with a sphere, I can do that. I can click the sphere, click on that top sphere, click the checkbox, and it's going to merge it in there as well. All right, there we go. We can do a cone. So let's do one more sphere, one more cone. So let's do with a cone, I do want to put another surface up top here on this guy. All right, we'll do insert cone, works just like the cylinder, only it's going to just kind of have some extended ends, which is fine. I'm going to say new insert so it doesn't merge into my part. All right, there's my cone, and then I'm going to do an insert cut with surface and cut the top of that cone off. So let's get that plane, make sure the correct body is set, and then cut away up. There we go. One more sphere. Make sure it's in the join so it merges the entire thing together. All right, there we go. So we've got an auto extrude, auto cylinder, sphere, and cone extractions inside this plane. Last thing I want to show you in this little group is the auto revolve. So if you want to just do the entire thing at once, cylinder and sphere, we click auto revolve. Click the regions that we want to revolve, and you can see here it's already building a sketch. Ooh, let me hold my shift to make sure I've got everything selected, but it's created a center vector and a sketch. All I got to do is click my checkbox, and it does that entire feature set at once. So individual components, you can do those components. And there we go. We got most everything done. There's a few other things we can do here. We got some pockets. I'll do these two. So another big function in this, and we'll get to the auto surface here in another example. But one last thing we can do is if I want to cut these pockets out, I can start by making a cross section. All right, and then it's going to ask me, which plane I want to start on. I'm going to start on this plane here, and it helps if I hide everything. So we're going to hide the solid body. Okay, let the graphics here catch up for a minute. While we're doing that, I'm actually going to close down VX Elements just so we're not taking up any memory here. All right, there we go. So what the cross section does is it allows us to drag a cross section plane through the mesh. And you can see there it gives us a cross section of the part. So went up a little too high. I'm trying to get these two pockets. All right, so we're going to go down a little bit more. All right, I want to cut through there. I want to cut through there. That's perfect. All right, and click my checkbox. So it's created a cross section, which is basically just like a spline. Now I want to use that spline to sketch on top of that spline. I want to sketch on this face because I think those are on the same plane as this piece. So what we're going to do is go right to our SolidWorks sketch tools, click on sketch. There we go. Okay. And now let's hide our mesh. And I'm going to use SolidWorks sketch features to sketch right on top. There we go. There's one. Let's do a vertical line. Oops, that's not the one I want. There we go. All right, I'm just going to drag another line out here. There we go. Let's trim these up together. So we got a corner trim. And again, these are all just standard SolidWorks, SolidWorks tool sets. So we'll do that. We'll go ahead and put a fillet between these two. All right. And obviously that fillet's too small, so let's start increasing that number. All right, so it's somewhere between on the high end and the high 0.2. So let's do like 0.2. I don't think it's 0.25. Nope. Let's go 0.2.7 or 0.275. And that looks like it matches, so I can see it overlays right on top of that cross section. All right, awesome. Now we're going to do the same thing down here. Again, all of your SolidWorks tools are ready to go at this point, so we're going to click that. Start. Here we go. Okay, I'm going to drag this outside of the body. Oops. Tell you what, let's just get rid of that guy. There we go. All right, let's draw a straight line out here. And same thing, we're going to use our corner trim to get this connected up here. And then we're going to use that fillet tool. Wonder if this is the same radius, we'll see. There we go, not quite. So this is probably 0.25. Yep, there we go. All right, so now we trace on top of a cross section. So you can use this for cutting through multiple profiles. You can use this for auto lofting, or not auto lofting, but help with your lofts and things like that. All right, so we'll go to our extrude cut at this point. Pull that up and out of the part. And there we go. So let's click the check box and we are pretty much done. The only other thing there is, I mean, there's that other pocket, and it would just be another extrude. I do want to show you guys some more, some more feature sets. But at the end of the day, once you get here, what's nice is we can go to GeoMagic for SolidWorks, and then if I show my mesh, all right, I can then check my deviation analysis to see how complete I've got. So it's going to ask us for a mesh versus a solid body. And so this is kind of the final step in the advantage of this software. If you do this stuff by hand or you kind of eyeball it, it's really hard to see. There's not really a good way to tell how accurate your final file is to the mesh that you've scanned. If you've got a creaform scanner and your stuff's accurate to a thousandth or two, you got to have the tool set to take advantage of that. Otherwise, you're kind of shooting yourself in the foot there. So with this software, we can tell just how close we are on all of our surfaces. That looks great. This is all plus or minus 10 thou. So you could adjust these. So we could run a plus or minus 5 and reevaluate that. So we'll click it one more time. There we go. And see just how our surface is looking. And this is an injection molded part, so 5 thousandths we may see a little bit of deviation, but overall our part, our part looks great. So we're pretty much done, and this is easy to see if you've got something missing. So if you model the part and you don't realize that there's a boss or there's a hole or something like that you need done, this very quickly outlines it so you can see right there. So that's the parametric functions, just a quick overview of the parametric functions of the software. All found up here and very powerful. I'm going to minimize that. All right, so if I want to do something, I want to do some mesh editing. Okay, as you can see here, not only do we have the parametric functions, we got some reference extraction, reference geometry stuff. We also have this mesh editing function. Okay, so if you're using a scanner that you need to do some heavy mesh editing or merging, stuff like that, this software can handle it. So we're going to start with a new file. Okay, here we go. And again, we import into GeoMagic for SolidWorks. And I'm going to choose this file right here. So just to be, in the spirit of the times, we got a snowman here. All right, so maybe you 3D scan this guy, maybe you sculpted it, or you just want to reproduce it for fun, who cares, whatever it is you need to do. And you want to make maybe a 3D printed part. So you hear the scan to print a lot. Well, it's not a one-click button necessarily, but having something like the creaform scanners, you can see, I mean, this is straight out of the scan, and this is awesome. And I was a very lazy scanner on this one. I've got a lot of data missing. Okay, this isn't what we would typically see or end up with, but I did want to have an example file. So if I want to maybe make a smaller version of this guy, and maybe make some edits, I can do all that. I can do a lot of that here in GeoMagic for SolidWorks. So first thing I want to do when I import a scan, especially I'm going to surface wrap it or I'm going to use it for 3D printing, is I'll check the repair tool here. So this is just a quick check that goes through and diagnoses the mesh. Make sure there's nothing. You can see here we've got there's always something, but we want to kind of zero these out. So here's all the defects that it can find. All we got to do is one checkbox click and it's going to fix those. So you can see here small tunnels, spikes. small holes, things like that. Stuff it can get rid of very quickly. So that's going to run, take just a minute. And now our mesh is pretty cleaned up. All right. There is a more, right under repair, there's a remesh. So if you've got kind of a pretty, nasty mesh, you can also use that, and that'll go through and re-triangulate the mesh. We don't have to do that here because our mesh looks really good. So we got a few options. Let's say you want to 3D print this guy smaller, or whatever you want to do, but you don't want it to have welcome. Maybe you're going to glue on your own letters you get from your favorite arts and crafts store that say Merry Christmas. So what we can do is we can go ahead and get rid of the welcome here. And how I would do that is I'm going to edit the mesh. All right. And I'm going to choose my polygon selection tool. And let's go ahead and get kind of normal to my screen here. So what I can do is just select around the current welcome sign. And I'm going to right click and say delete. So it's going to leave me with a big hole. Now it's also, depending on the triangles or how they're facing the screen and things like that, you may get all this trash here. And this is pretty common too in a raw scan data set. Something you may use, converted scan from a point cloud or whatnot. You get this, you get a lot of nasty, with the scan, you may get some artifacts floating around. So one click button to get rid of this. We go up to detach triangles. Click on the, make sure the mesh is clicked and click the checkbox. All right, what that's going to do is get rid of every little piece in the mesh besides the main one. And now we're ready to do some serious mesh repair. So if I want to get rid of, I want to get rid of that hole and make a solid sign, we've got our hole fill holes here. All right, and I've got flat, tangent, and curvature. It basically goes from flat to, following the feature curves to the edge to the curvature, doing some heavy curvature. So we're going to use a tangent. It's usually what I use because it does a really good job. I right click on that, and boom, there we go. Hole, the hole in the sign is filled. All right, so as we move on, I can look at the part and I can see, there's a lot of stuff missing here, right? So I can click on curvature fill because there's a lot more curvature in here, and I can start individually clicking on features, okay? And these are some pretty easy ones. If I select the hat, there's not a lot of geometry there, but it literally moves it to where you can't see that hole. A pretty challenging one, and I was pretty happy with how it did on this. So the underside of this hat, that's a huge void in the scan, but if I click on it and tell it to fill that hole, I mean, you'd never know that was not scanned and then it was hole filled. The software just does that good of a job at hole filling. So I can go through and I can click all the individual ones, or I can say just fill all holes, and it will fill all the remaining holes with the curvature. We're going to click that checkbox, and that's going to give us a completely watertight mesh. So that's the process of scan to print. Now this guy I can put right on any 3D printer. I can save it as an STL and put it on any 3D printer and print him just like he is. So extremely fast way to get from a scan to a 3D printable file. Or we can do what we're going to talk about in the next step is actually rapid surface him. So if you physically needed to use him for something in SolidWorks, build something around him, we could use the auto surface function. I'm not going to do it on this guy because he is very complex. It will take more time than I think most of you are willing to sit around and watch the screen crank. So we're going to move to another example, but I do want to wrap up the mesh editing function. Again, that's all under this tool set. So again, 9 tools that are very, very powerful. All right. Again, if you got questions, type them in on the chat, and I'll definitely get to them. So let's minimize this guy. All right. We're going to move to our final, kind of heavy hitter tool set in this software. Again, we're going to make a new part. Okay. So we're in our third, we're in our third part in SolidWorks. Again, import one last time. So I scanned a kind of auto surface part earlier. Makes for a good example, I think. So not nearly as complex as a snowman, but it definitely get the show you the advantage of this. So let's say you've got a part like this. You could use the geometric features to reverse engineer it, but you wouldn't necessarily want to. It's kind of tough. You definitely do it. There's not really a faster way than any of the GeoMagic products. But let's say you want to make some sort of fixture that's going to perfectly mesh up with a portion of this part for, you know, to hold it in place for some sort of machining operation. But you don't have the CAD file of the part. Well, we can do that here. So I'm going to click on Auto Surface. All right, and there's a couple of settings in the Auto Surface. One, select the mesh. You know, so there's the mesh right there. We've got geometry type. We can either choose mechanical or organic. And I'll kind of explain the differences between those two. On this part, I would want mechanical. And then on patch count, so you'll see what this does. It basically makes a bunch of patches on the part. I want to let it auto estimate. I don't want to limit it to something. You also have a surface detail slider. There we go. It can kind of crank it up a little bit more. Pretty similar to the you know, the extract freeform. You're kind of giving it some leeway to, you know, leave out some detail or really like perfectly match up detail. You know, it may take a little more time to do the higher surface detail. This one, there's not really any detail, so we can kind of leave it right there in the middle. Adaptive tolerance, I just kind of leave it. It auto estimates this value here. So when I click my checkbox, again, other than your settings, you got one click, and it's going to evaluate that mesh, and it should spit out an auto surface here in just a minute. What it's doing in the background is it's laying down a bunch of 3D splines across the mesh in a pattern that will flow with the feature lines of the part when we use the mechanical. So the reason we would use the mechanical is we want something that looks really nice. Let's go ahead. You know, it's still cranking away here. Just be a minute. But we want something that'll be aesthetically pleasing when we turn the edges on. It's going to look more like a CAD file because you'll see the feature lines will actually flow with the scan data set. Whereas the organic is going to be a little more random. All right, here we go. It's finishing up. And now you can see we have a part in here. So if I hide my mesh and I show my surface, there we go. So we now have a surface. If I show my edges here, so this is an actual CAD feature now. Now it's not parametric, it's not feature based. It's basically a shrink wrap surface over the mesh. But what this does is it allows SolidWorks to use the software, use the file a lot better. So if you got a part like this that you're trying to send to a customer or a boss or someone else in your department, and they don't have the ability to use an STL like you do, if you've got this, you can do a surface wrap and you can send it, and SolidWorks has no problem with these. It's basically what we call a NURB surface. It's a very common file type. But you can see here with the mechanical feature selected, all the feature lines have these, you know, the lines kind of flow with the features. So if I hide this and I run that one more time, so we're going to do our auto surface again. I'm going to click organic this time and then click my checkbox. I expect it'll take just a little bit less time because we're not really constraining it to feature lines. We're letting the software figure it out. But again, we're just running it. And what you'll see at the end of the day is really an equivalent file. It just depends on how you want those feature lines to flow. All right, so it should be done here in just a minute. Again, if you got any questions about the parametric workflow or the mesh editing workflow, feel free to let me know. While this is cranking away, it should be another minute. I could certainly answer a couple of questions. All right, just about done here. And again, this, those of you who aren't familiar with what we're doing, or this is pretty new to you, we're taking an STL from a scan that traditionally can't really be analyzed by a CAD file, and we're wrapping a surface over it that SolidWorks or some of the software can actually interpret very easily. All right, so if I hide my scan again, you can see we essentially get the same file. If I turn my edges on, it still kind of follows the lines, but the patch is a lot more sporadic. If you're wrapping something like that snowman in the previous example, you would use the organic because there's no real feature lines you want to wrap. You just want to get it as, you know, let the software do as good of a job as possible. But if you see here, if I turn the edges off and use one of the SolidWorks tools, so let's do features and then move. I'll just click one of these guys here and drag it over. Doesn't really matter which one. There we go. Okay. and show the old one. So they're pretty, you can't really tell the difference between them other than the turn the edges on. All right, but what would I do with this? So now I have a feature, or say a part that I can use for cutting a model. So let's hide this one here. All right, let's just say that I've got this weird surface that I need to make a tool that will perfectly match. So go right to my sketch, use the SolidWorks sketch entity. All right, let's choose, let's sketch on the top plane here. And I'm just going to draw a box. Let's say we have to match up this location of the part. All right, we got some sort of abutment that it's going to go right there. We're going to make that sketch, do an extrude. I'll go ahead and run this as a mid-plane extrude, pull it out. All right, there we go. Maybe that's our tool. Okay, so again, SolidWorks functions all the way. We go to cut with surface, select that surface, and just make sure it's cutting the right direction. So I want to cut, maybe we want this side of the tool, so going the right way. There we go. And now we've perfectly duplicated that geometry of that part onto what would be otherwise a parametric fixture. So that's one of the reasons why you would use that auto surface. We use it all the time here. It's a great tool, and GeoMagic was awesome for including it in their GeoMagic for SolidWorks suite. So that's the end of those are my 3 examples. That's kind of the end of the presentation here. Definitely let me know if you got any questions on anything, you need to see anything again. I've got all those files open. If you have any questions on the 3D scanners, feel free to ask. So hit up the chat there and let me know. I'll give you guys a minute. While you're doing that, again, GeoMagic for SolidWorks is $7,900. So if you've got a SolidWorks license that you buy GeoMagic for SolidWorks, install it, and it plugs right into your software. And if you want to give the software a try, you can definitely reach out to us. I'll put up that info in here in just a minute, and we can get you a free evaluation copy along with some, I can get on the phone with you and give you some pointers. If you have any questions regarding 3D, 3D scanning, any of the reverse engineering or metrology questions, definitely feel free to reach out to me directly. Email's probably, email is definitely a great option because I can check it anytime. Kenny@neometricstech.com. All right. Yep. Thank you, everyone, for joining me. We'll go ahead and wrap it up here, and look forward to talking with you guys next time. Have a good rest of your day.